Hi, welcome to clickmeproject.com. Now let me discuss about the project title of project title. The project title is the indicator surface drought index as an indicator for agricultural drought monitoring, theory, validation, and application in Middle East and China. The modified title for this process is a machine learning perspective for predicting agricultural droughts. Actually, the main objective of this process is we are going to predict the agricultural droughts in the Mid-Eastern China areas by using the rainfall precipitation rates overall during the years of 2010 to 2014 years. In this, we are going to predict the agricultural droughts by using a machine learning perspective. Means we are going to predict the agricultural results by using an algorithm called Naive Bayes classifier. So this is the main objective of the process. Now let me discuss about the abstract of our process. Normally, drought affects a large number of people and cause more losses to society compared to other natural disasters. China is a drought disaster prone country, so the frequent occurrences of drought poses an increasing severe threat to the Chinese agriculture productions. So drought also has very complex phenomenon that is difficult to accurately quantify because its immense spatial and temporal variability. In the existing system, implement the ISTA model construction for evaluating the accuracy and the effectiveness. This model application using a variety of methods and data, there is still some work to be done in our future results because of the complex spatial and temporal characteristics of draft. So, to overcome this limitation, it assesses performance of measuring the drought by using the spatial and temporal characteristics of informations. We collect the data set from different regions and also collect the time-varying informations like that. In this, we predict the drought conditions by using the supervised learning mechanism. It can be implemented by using the Bayesian supervised machine learning algorithm. Through this, we can achieve the accuracy and performance, and also we can improve the performance and effectiveness. Now let me discuss about the data flow diagram of our process. So first our process starts with input selection. Our domain is data mining. So first we have to select the input. So our input is a data set. After we choose a data set from the file location, we have to pre-process the data set. After we pre-process the data set, pre-process is nothing but a data cleaning. So in this we have to eliminate the unwanted symbols or unwanted values or cleaning the unwanted values in the dataset. That is called dataset pre-processing. After the dataset has been pre-processed, we are going to classify the attributes in the dataset. So here we are classifying the dataset by using the attribute values, such as by using the month-wise predictions. After that, we have to predict the drafts based on the Naive Bayes algorithm. Naive Bayes is normally the condition probability process. After we have to predict the soil moisture level. Then based upon the soil moisture and drafts, we have to predict the crop yields. After that, we have to evaluate the performance of existing and proposed system by using the time efficiency and then accuracies. This is the data flow diagram of our process. Now let me discuss about the complete demo of our process. First we have to run home.java. Just right click and run the file home.java. That home page will be displayed here. And our title is a machine learning perspective for predicting agricultural droughts. After run the homepage.java, then just click the frame. Just browse your input from your locations. Here we have a data set in imd.districtwise rainfall dataset CSV. So this is the data set we are going to use in our process. So this in this data set we have attributes like state and then district, year, then rainfall rates of January to December, then annual rainfall rate and total rainfall rates and soil moisture level and elevation level. After we get the data set values, we have to convert the data set into AR format. So after the CSV file has been converted into the AR format, in this we extract the data set formats like attribute relationship format. In this we have a relation name, then attributes names, and then for a particular attribute we have a number of records like data that is extracted in a data. After extract the data, convert the data into the AR format, ARF format, we have to create the table in a database. Table has been created. After the table created, we have to load the data into that table. Data has been extracted. After that, we have to view the data set from the database. Then click extract. Here is the data set view from the database. After the data set has been extracted, we have to classify the data set based on the attributes. So just click the classify. So based on the districts, like that we are classifying the data sets. After the classifying the data sets, we have to cluster the values. Here we are clustering the values based on rainfall rates for year wise for 2004 January, February, March, April. Here we group the districts based on the low rainfall rates. September, October, November, December, then May, June, July, August. Then if you are going to click for May 2005 means you can get this some type of results. So here we are predicting the rainfall rates districts during the year 2004 to 2010. After just click the next button. Here we are clustering the informations based on the annual rate. So based on the annual rate, here we cluster the values. After we cluster the values, we are going to apply the new Bayes algorithm. Here we are applying the new Bayes algorithm P of A, then P of A intersection B. Then here we are calculating the P of A conditional B values. After that, here we are by using the Bayesian values. Here we calculate the matrix value, then information gain value, then entropy values, then gain values. After that, we are classifying the districts and cluster values. After that, we predict the classifier values. Then here we aggregate the values based on the cluster and district levels. So after that, click next button, then click result. Here we have districts and here that entropy values. Just click the draft affected regions. So based on the some ranges like low, medium, high ranges, here we evaluate the results, predict the results. Then just click the evaluate button. Here we display the graph based on the draft affected regions in the districts. So after that, you have to, in the process we enhance the process by using soil moisture and elevation levels. By using these type of levels, we are going to predict the crop yield productions. So just click the crops and capacity. Here we have a crops and its capacity levels. Then click next button. Then here we are calculating the for each district. Then we can get the total capacity of each district. Then if the capacity is 3.62 means we predict the crop yield levels of that level, then districts. Then so based on that level, we have what are the crops, and then the districts will be displayed here. Then click evaluate. In this we evaluate the performance of existing system and proposed system by using the time taken. This is a complete demo of a process. Thank you for watching.